The atmosphere was electric with quiet anticipation as the European Space Agency, ESA, finally decided to draw back the curtain on the latest data gleaned from the camera of one of its valiant orbiters circling Mars. The news rippled through the scientific community with the force of a cosmic shockwave. It appeared they had successfully documented the presence of the elusive interstellar visitor 3I Atlas. This object, thrust into the spotlight upon its discovery on July 1, 2025, had already established a reputation for being profoundly anomalous, defying easy categorization and challenging accepted paradigms of celestial mechanics. The sheer mass and scale of the object were compelling enough, but it was its orbital geometry that truly snagged the imagination. The path it carved through space was discovered to be uncannily aligned with the ecliptic plane, the very plane where the planets of our solar system make their leisurely rounds about the sun. This alignment, far from being a random coincidence, presented an unprecedented opportunity, a celestial gift if you will, a highly visible, conveniently positioned target that was now within the observational purview of a multitude of our sophisticated space probes, both orbital and deep space bound. It was a chance too rich and too rare to ignore. Just a few days prior, precisely on October 3rd, the visitor executed a dramatic, close flyby of the red planet, passing within a relatively tight corridor of 29 million kilometers. The camera system, functioning flawlessly, managed to capture the fleeting presence of the object. What the resulting image revealed, however, was not the anticipated spectacle, but a puzzle, a mere ball of light characterized by a slight, almost indistinct extension. This form was entirely inconsistent with the classical, majestic image of a comet, that familiar celestial body defined by a brilliant, beautiful tail of volatilized dust and gas stretching dramatically, always retreating from the oppressive force of the sun. Its appearance was stubbornly, intriguingly anomalous. This new data point resonated eerily with a previous enigmatic observation. On July 21st, the venerable Hubble Space Telescope had delivered a portrait of 3I Atlas that was equally baffling. That image showed a puzzling extension of the object. Yet this luminous jet was oriented toward the sun, directly contradicting the physics that dictates cometary tails must be swept away from solar radiation pressure. It was as if the object was actively ejecting material in a defiant sunward direction, a behavior that no known natural comet has ever reliably exhibited. The mystery only deepened with the Mars pass. While the European data provides a tantalizing glimpse, the true prize, the data point everyone in astrophysics is clamoring for, is yet to be released. This ultimate resolution is promised by the high-resolution imaging science experiment, HiRISE camera, a monumental instrument situated aboard NASA's Mars Reconnaissance Orbiter, MRO. We have confirmation that the data was successfully acquired at the optimal moment on October 2nd, the perfect temporal capture of the interstellar object's closest approach. However, a maddeningly familiar, purely terrestrial complication has intervened: the government shutdown. Consequently, these potentially breakthrough images remain classified, locked down, and entirely inaccessible to the public and the broader scientific apparatus. The HiRISE camera, boasting a half-meter mirror, is capable of delivering an astonishing 30-kilometer resolution of 3I Atlas. This resolution is not merely a technical achievement. It is the key to unlocking the object's true physical dimensions. The light reflected from its surface will establish the brightest pixel in the image, a quantifiable metric that will allow scientists to deduce its mass and size. The old wisdom that a picture is worth 1,000 words has never felt more urgent. The highest resolution evidence ever captured of an object from beyond our star system sits frustratingly on a server, awaiting a political resolution. The delay is maddening, a self-inflicted wound upon the progress of knowledge. The voyage of 3I Atlas is a meticulously mapped, month-by-month itinerary of cosmic encounters. In the coming weeks, the interstellar interloper is scheduled for a close encounter with another crucial space asset, the JUICE, Jupiter Icy Moons Explorer mission, presently en route to the outer solar system. That conjunction will occur sometime during November. However, the event generating the most intense scientific debate is slated for just before that, on October 29th, when 3I Atlas will plunge to its perihelion, its closest distance to the scorching presence of the sun. It is at this point that the object will endure an extreme thermal environment, and the central, most compelling question is its reaction. How will this foreign, likely primordial body respond to the intense solar radiation? Following this fiery passage on the threshold of the holiday season, specifically December 19, 2025, it will make its closest pass to Earth, though it will maintain a safe distance equivalent to approximately 1.8 times the separation between the Earth and the Sun. Its farewell to the inner solar system will take place on March 16, 2026, when it hurtles within 54 million kilometers of Jupiter. The scientific community holds on to a shared hope that NASA will actively redeploy its Jupiter-orbiting Juno probe to seize this final opportunity to collect further invaluable data on the object's properties and behavior before it disappears back into the interstellar void. The very scale of 3I Atlas, combined with its anomalous behavior, forces a collective contemplation that extends far beyond standard astrophysics. It compels us to consider the possibility that this might be something far more complex than a simple frozen rock of ice and dust. The contemplation pivots toward a dramatic paradigm-shifting possibility. What if this massive object is a technological artifact? What if it was intentionally designed by a sophisticated unknown intelligence, deliberately choosing an orbit that aligns with the established planetary plane of our solar system for a reason entirely unknown to us? The very thought suggests a reality for which the human race is profoundly unprepared. The Harvard astrophysicist whose voice drives much of this speculation views 3I Atlas as a vital wake-up call, a signal that we must dramatically increase our vigilance regarding potential risks originating from beyond our cosmic doorstep. This sense of existential urgency is the direct impetus behind the recent submission of a white paper to the United Nations. This document passionately advocates for the immediate establishment of a dedicated international committee. The singular purpose of this body would be to rigorously analyze all future data pertaining to interstellar objects, explicitly looking for any persistent, unexplained anomalies that could signify the presence of alien technology. The frustration over the delayed HiRISE data has naturally led to the predictable yet unfounded whispers of conspiracy, suggesting that NASA is deliberately concealing evidence of extraterrestrial intelligence. The prevailing and much more grounded scientific viewpoint counters this. The delay is not the subtle fingerprint of an alien presence, but rather the heavy, unmistakable hand of terrestrial stupidity, a failure of governance, not a success of alien camouflage. Yet, the core drive behind the research remains unshakable. The central question, are we alone, is arguably the most romantic and most fundamental inquiry in all of science. Finding an intelligent partner in our vast cosmic neighborhood could give entirely new meaning and purpose to human existence. However, this hope must be balanced by a profound, precautionary fear. Any cosmic blind date with an unknown alien technology must be treated with the utmost seriousness, as the possibility, however statistically low, of a devastating black swan event, an encounter with something akin to a serial killer, cannot be entirely discounted. This duality of hope and apprehension has tangible policy implications. The strongest recommendation currently being championed is the urgent need to establish a second major observatory in the Northern Hemisphere. This new facility would serve as the complementary twin to the already operational Rubin Observatory in Chile, which is limited to monitoring the southern sky. This effort, estimated to require an investment of approximately $1 billion, would finally complete a comprehensive all-sky alert system, ensuring that no interstellar visitor, rock, or artifact can slip into our solar system unobserved. Should a verified encounter occur, the subsequent level of global investment in defense and study would need to escalate dramatically, perhaps by a factor of 1,000, bringing it into parity with the annual expenditures on military budgets. A threat emanating from outside the solar system would not only be an existential security issue, but one that could severely disrupt the very foundations of the international financial system. The sad, frustrating reality is that the HiRISE instruments functioned perfectly, capturing the essential data on October 2nd. Researchers at various academic institutions have the capability to analyze and process this information. But the shutdown imposes an absolute, non-negotiable silence. The data cannot be shared, it cannot be discussed publicly, and it cannot be leveraged, even as our international competitors, the European and Chinese space agencies, continue their work. This deliberate, politically induced silence is actively detrimental to the pursuit of knowledge. The scientific community is united in its fervent hope that this political obstacle will be overcome in the immediate future, allowing the vital, exciting work of studying this extraordinary interstellar guest to continue with the urgency it demands. Everly disrupt the very foundations of the international financial system.